Good day, math buddies! Sir Sherwin here, your math instructor. Welcome to another content where we are learning all about mathematics in an exciting and interesting way. And for today's video, we will learn on how to determine the equation of a quadratic function when graph is given. But first, please don't forget to subscribe on my YouTube channel and hit the notification bell for more updated contents. Alright, dear math buddies, welcome to my YouTube channel. And today, we will discuss on how to find the equation of a quadratic function when graph is given. Are you ready? But first, let's try to remember some significant ideas on how to determine the equations when graph is given. First, make sure you can identify the coordinates of our vertex, which is represented by h and k. And second, identify also a point that is present along our parabola. Third, substitute these coordinates into our vertex form or standard form. So join me as we determine the equation of a quadratic function. Let's try to find out. Let's try to look after our graph. If we notice, this parabola opens upward. And we've learned in our previous lesson that when our graph opens upward, it follows that our a is greater than 0 or a positive number. And if our graph opens downward, it follows that our a is less than 0. So for this parabola, we are expecting to have a positive value of our a. And later, let's try to find out and prove if it is correct. Second, let's try to identify the turning point of this parabola. I am referring to the coordinates of our vertex. If we notice in this graph, the parabola turns exactly at a point with coordinates 4, 0. Then, let us also determine any point that is along our parabola. And if possible, we can choose a point that gives us an exact value of our coordinates. So we will choose only one point with specific coordinate. And in this case, allow me to utilize a point with coordinates 2, 4. Again, the things we need to remember would be the coordinates of our vertex and a coordinate of a point present along our parabola. With this, let's try to have our first equation. So for our vertex, we have the coordinate 4, 0 and a point with coordinates 2, 4. So using our vertex form or standard form, let us try to solve for a first. Of course, the value of our a plays a significant role because it will lead us in the direction of our parabola. So let us try to solve for a first. Using our vertex form or standard form given as y equals a times the quantity x minus h squared plus k, substitute the coordinates of our vertex, which is represented by h and k, and the coordinates of our point present along our parabola represented by x and y. So using these values, we will be solving for a. So here, our y is 4, a is unknown, x is 2, while our h is 4, squaring it, and of course, we will have our k, which is represented by 0. We will simplify our given equation. So we will have 4 equals a. So 2 minus 4, we will have negative 2 squared and adding 0. That means we will add nothing. So again, let's try to simplify. So we'll have 4 is equal to, so first let's try to square negative 2. And squaring negative 2 will lead us to a positive 4. So positive 4 times our a, the product would be 4a. Since we are solving for a, and a here has a numerical coefficient of 4, so we will try to divide both sides by 4. In order for us to cancel out the coefficient of our a. To simplify, it will lead us to a result which is a equals 1. In this case, our a is greater than 0, and it follows in our graph earlier, we have a graph that opens upward. After we identify the value of our a, the next thing we need to do is to utilize the value of our a and the coordinates of our vertex to find for our equation. So let's now find the equation using our a, h, and k. Again, using our vertex form, we will have y equals a times the quantity x minus h squared plus k. So by substitution, we will have y equals 1, which is the value of our a. Then we will copy our x minus our h here is positive 4. So we'll have positive 4 squaring it and our k, which is 0. Then we need to simplify. So we will try to copy 1 equals, since our a is already equal to 1, so it is okay for us to not to write 1 in our given expression. So we will try to copy only the square of the binomial, and that is x minus 4 squared. And adding 0 will also means adding nothing. So we will not try to copy 0 at all. In this case, we can consider this one as the vertex form of our quadratic function. So this is our vertex form. And to write this one in general form, all we need to do is to expand our square of a binomial. And that is y equals, expanding our quantity x minus 4 squared will lead us to square of our first term, that would be x squared. Get the product of two terms, x times negative 4, we will have negative 4x. And this product will be multiplied to 2. So x times negative 4 is negative 4x times 2, that would be negative 8x. And for our third term, we will get the square of negative 4. So squaring it, that is equal to 16. So this becomes the general form of our quadratic function. So we have the general form of the quadratic function given as y equals x squared minus 8x plus 16. So this is how to obtain our equation when graph of a quadratic function is given. Let's try to have our second example. Let's try to look after our second graph. And in this case, the graph opens downward. And again, we will be expecting that our a will be less than 0 or a negative result. So let's try to find out if we will get it right. So we will have to identify the coordinates of our vertex. And using this graph, we can consider that the vertex has a coordinate 0, 4. And we will choose one point that is present along our parabola. So allow me to utilize 2, 0 as my point. So we will have the coordinates of our vertex represented by 0, 4, and a point represented by 2, 0. Again, we will solve our a. So that is using our vertex form represented by y equals a quantity x minus h squared plus k. Simply substitute our h, k, x, and y in this standard form. So our y here is 0, a is unknown, x is positive 2, h is 0, squaring it again, and our k is represented by 4. So, all we need to do is to simplify first our given equation. So, we will have 0 equals a. We will have 2 minus 0, that is 2, squaring it, and copy positive 4. Let us simplify. So, we will have 0 is equal to 2 squared, that is 4, times a. We will have a result of 4a. Then copy our constant, which is positive 4. Since we are solving for our a, so we need to transpose positive 4 to the left side of our equation. So transposing it to the other side will change its sign. So we will have negative 4 is equal to 4a. Then we will divide both sides by 4. So we can cancel this out. So a here is equal to negative 1. So it gives us a value of our a which is less than 0. And it follows that our graph here opens downward. So after we obtained our A, the next thing that we will do is to use the value of our A, the coordinates of our vertex, in determining the vertex form or standard form of a quadratic function. So let's try to find out now the equation. By using our vertex form, y equals a times the quantity x minus h squared plus k. So by substitution, we will simply substitute our a, which is -1, then our h, which is 0, and our k, which is +4. Unlike in our first example, our a here is a negative value. So we need to specify the negative sign before our square of a binomial. So it is still okay not to write 1, but it is very essential for us to have our negative symbol before our square of a binomial. So to write this in simplified form, that leads us to y equals negative x squared plus 4. So this can be both the vertex form and general form of a quadratic function. And this becomes our final answer. Y is equal to negative x squared plus 4. There you have it. Hope you learned something new today. God bless us all.